together so that it doesn't appear choppy. We started here. We're trying to prove that if x is in the neighborhood, epsilon neighborhood of A for every epsilon, then x is equal to A. The more obvious the statement, the harder it is to prove. So what do we know? We know anything between the if and the then. So we know A belongs to the reals. We know x belongs to the epsilon neighborhood of A for every epsilon bigger than 0. And I expand the know. That's from the proofwriting wiki, which we should be using all the time. That's, you know, if you, you're really just organizing your thoughts. So what gives me these things is theorem 2. I write little labels to myself. You're going to see the clean proof later, but I write little labels so that I don't have to go hunt in the book again. So if you have me for ODEs, you know I'm lazy. So I'm like, okay, I just want to write this once. So I make a little notation to myself, like this is theorem 2.2 that allows me to do it. Sometimes I do what I want to do, and then I go back to the book to find if there's actually a theorem to go with it, and I'll label it. Sometimes the theorem's not there, so then I prove it. Because I'm kind of like stubborn and trying to go one path. So I rewrote everything in terms of a version that I could see, and then I plotted that. So you should have this already in your notes from last time. So I'm making like very clear what this means. So I think my confusion when I first started writing proofs is, why do I have to write something that's totally obvious? And I remember my honors calc teacher sitting with me in a linear algebra class. I had a guy that was making us prove a lot of things. And she said, write it down. And I just looked at her like, but I know the definition. Why do I need to write it down? So you just need to have everything decomposed so that you can really understand what you're doing. You may not feel like it, but this is a gift because it's going to make you feel like you can read anything and figure it out. I took a class called virology. I had to take a minor in another science, but all the courses had to be senior level or above. And I thought, viruses, I know viruses. I'll take virology. Well, you apparently have to know molecular biology to take virology. And molecular biology has a lot of like terms in it. So like the teacher was talking and I had no idea what he was talking about. And all the students in the class were senior biology majors. And I went to the library and I wrote out notes. Got the top score in the class. Like it just gives you that confidence. Like I know how to read something and figure this out myself. And this is what we do. And it separates us from engineers. Not that there's anything wrong with that. Okay, we have to show x is a. We write that down. Why do we write that down? So we don't accidentally use it in our proof. It happens. Okay, I pulled out facts that might be useful to me. I pulled this one out. I mentioned this already. I pulled this one out because I felt like it would be useful to me because it has epsilons in it. My theorem has epsilons in it. It has absolute values in it, or something to do with a is bigger than 0. It has an a equals 0. My thing has something with 0 in it. So I kind of set up a little strategy and replaced things with what Bartle's definition is. And then now we're going to do this proof, right? That I kind of led you through this. So we're going to prove this. I know you hate this color. It's already been done. I won't do it again. Here's my know. Here's my show. And then I gather facts from Bartle. So this is the proof we started writing up. That's where we ended up, right? So I go through Bartle. This is why mathematicians like books and not ebooks. So you can actually thumb through it and make notes of where you're using it. I don't have a Bartle that's hard copy. Mine is it's like freely available now. So it's annoying for me to slide through that and try to find things, but you just make notes of what's relevant. And I found, of course, theorem 2.2 seems like it's relevant because it's got an inequality with both sides on it. And this has an inequality with both sides on it. So it seems like it might be relevant. So I pulled that fact. Kind of looks like my show. the tidyverse of real analysis. You have to filter what you get because the more we go on in the book, there's going to be more and more stuff in there. So you can't just put everything down. So you have to have a mechanism to filter. So tidyverse it. Good? Okay, some more facts. I'm also go through the examples, and you'll also notice I go through homework problems too to see if any earlier homework problems might be relevant to me. I just go through the whole thing. So if I get a revision back that says you should do this homework problem, then I do it. But other than that, I try to use it. On 2.26, he adds and subtracts across inequalities like this, so it allows me to do this. Now what I'm trying to do is reshape it so I can use theorem 2.2. So I'm trying to reshape things. So I get that. So I'm just playing around with the facts. That's all I'm doing. Some more facts. Well, if x, I just noticed this, x minus a is bigger than 0. Well, then in that case, absolute value of x minus a is x minus a. And b minus a is bigger than 0, so the absolute value of b minus a. I'm just writing down that fact so that I can use it. So what about the other inequality? I'm going to lay out the facts for the other inequality too. Same thing. I forgot what I was going to show, so I just rewrote it.
I was going to ask, we're not 3 slides deep into the know.
Yeah. So I wrote it down just one more time. You have it on paper, so I used to have paper spread around my desk so that I could see everything all at once. So I don't want to forget what I'm trying to show. And I think what my honors calc teacher was trying to tell me is slow the hell down. Slow down. Because I was so bent on trying to solve whatever it was in front of me, because that's how you do calc problems. Integration by parts, you slap it down, get it done. So there's no like thinking in between. Somebody got mad at me once when I said there's no thinking. A math educator. Like, there's no thinking. If Mathematica can do it, there's no thinking involved. Okay, so now, this is just my scratch work. I wrote down the facts that I have. I started labeling it. I wrote down my show, and I have some scratch work here. And the scratch work, the reason I'm doing some of the scratch work now is I look at what I have to show as x's and y's together with one inequality with b minus a. So now I'm trying to take the things that I know and I'm trying to rewrite it so it looks like I can get an x minus y into play. That's what I'm trying to do. So this is my scratch work. From a and y is less than y is less than b, I'm going to try to get an x involved by first making that minus y so I can get it to look like this. And then adding x all the way through. So I'm just playing with it. By 2, I have x minus a is less than b minus a. But I also have x minus a is bigger than x minus y for my scratch work above.
Can't you just go, like, you know y minus a is greater than 0, which means you have y is greater than a. And if x minus a is less than b minus a, doesn't that imply that x minus y is also less than b minus a?
Sure, that's where I'm going. But I'm right. I'm listing everything from a fact that came from Bartle. I can't just go, right? I have to like go back and document my work. So that I'm just slowly going through it.
Okay.
Speed is not your friend in this class. We're halfway there. And I did something here. I multiplied through by a minus sign. I'm not sure I can do that. So I went through the book and I found he did that on page 33. So I can use it. So that's the problem with firing forward and just using things. You don't know if you can use it. And you might use something that's supposed to be proved. So now I have documentation. I did the same thing with the other side. I did this. So my students usually follow what I'm doing with the arrows. That's my habit. Like I put everything up that I think I want to do, and then I start putting the documentation on. That's not how everybody thinks. If you're somebody that has to have the documentation as you go, you should do it that way. Like this is how I think. I throw everything up there. If you've been to my office, it's complete chaos. And then I start reasoning why I'm allowed to do things. And so as far as I know, this arrow thing is like my thing. I've done that all the time. And I do the same thing here with the X inequality and use 1, and I get X minus Y is bigger than minus B minus A. And I'm done by theorem 2.2. Because this is not the clean proof. The clean proof is not going to have all this mess and stuff and putting it together. I'm going to show you that in a second. Some of you are thinking of going to grad school after you finish. If you go to grad school, don't avoid taking a major that requires pure mathematics in it. We tend to have that happen. People go to an OR program that doesn't have math, like proofs in it. Put your head down and barrel right through it, because once you know how to do this, you can take any program. And Colonel Laporte, if you knew him, he went through the math program at Georgia Tech. He took abstract algebra, he did the whole thing. So it just makes you more powerful. One of our young captains went to Baylor with a very rigorous stat program. He had a lot of proofs to write, and he just came out of that straight and became an AP here. He's not even here as a senior rotator yet. Like, it just makes you so powerful. So that's my advocacy to don't be afraid. Go hit it, because everybody can do it. If you're in this class, everybody can do it. Okay.